This is a video for Lab 1 for Physics 1050. This video is going to take you through the basics that you need to do your uncertainty calculations in lab number 1. So in your experiment, the first part, when you do your 8 trials, you're going to measure the position of the front end of the cart on the track and the back end of the track. You're going to subtract those two distances to get the total displacement of the cart. I'm not going to do the same numbers you would have in your lab. I'm just going to make up some example numbers and we'll go from there. So let's say that the first position, D1, is at 25 centimeters. And let's say I've estimated my uncertainty to be 0.1 centimeters. And let's say my second position was at 50 centimeters. And let's say that uncertainty was 0.2 centimeters. Okay, these are just some numbers I made up. Your track, the first distance will probably be about 17 or 18 centimeters, and the last distance will probably be about 110 centimeters. So to get the displacement, our displacement that we'll call x will be d2 minus d1. Those two numbers are pretty easy to subtract. That's 25 centimeters. So 50 minus 25 gives us 25. For our uncertainty, the uncertainty in x, delta x, this means the absolute uncertainty in x. If ever we add or subtract numbers, we add up the absolute uncertainties in those numbers. So that's our addition rule. So the absolute uncertainty in x is the absolute uncertainty in d2 plus the absolute uncertainty in d1. 0.2 centimeters plus 0.1 centimeters equals 0.3 centimeters. That means if we write down the position or the displacement of our cart, it's going to be 25 plus or minus 0.3 centimeters. So that's how we write the position with its uncertainty. Let's say we found our time, and your lab gives you a way to calculate the uncertainty in your time. Let's say we found our time to be 4.50 plus or minus 0.02 seconds. Okay, so here's our displacement, here's our time. The next part of your lab, so you're going to have 8 variables of time, so you'll have 8 different sets of time, whatever they are. Then you're going to go to your computer and you're going to calculate, you're going to put in all the values in the computer, okay, because we want to use the computer. Oh, let's just back up a step. In the first question of your lab report, you have to do some sample data calculations. Okay, yeah, let's do that part first. So you're asked for trial number 1 data only. Let's say this is our x for trial 1, and this is our time for trial 1. You're asked to find the relative uncertainty in x. So relative in x. The way we calculate a relative uncertainty is we take the number for the absolute uncertainty for the number and divide it by the number itself. So the uncertainty divided by the number. The relative uncertainty is delta x divided by x. 0.3 centimeters divided by 25 centimeters. Notice that your centimeters cancels. You don't have any units with delta x over x. When we do that in the calculator, we get 0.012. We always round uncertainties to 1 sig fig. Okay, so there's our relative uncertainty in x. You do that in question 1. You're also asked to find the relative uncertainty in time. And this is just for your first trial. So likewise, we do the uncertainty in time divided by the time. Delta t divided by t. 0.02 seconds divided by 4.5 seconds to give us 0.004. Again, this is an uncertainty, so it rounds to 1 significant digit. Uncertainties are always 1. The next part of question 1 is to find the relative uncertainty in the velocity. So to find the relative uncertainty in velocity, the line here, relative in speed or velocity. So to find speed, we know that v is distance over time. This is a division. We divide two things to get the speed. That means we use the multiplication division rule to find the uncertainty. That rule says delta V over V equals delta X over X plus delta T over T. Okay, this is good. We want the relative in speed. We know the relative in X. We know the relative in T, so we can calculate the relative in V. Delta V over V equals relative in X, 0.01, plus relative in time, 0.004. We add those up and we get 0.01. Again, rounding to one significant digit here. Okay, and then the last part of that question is to find the absolute uncertainty in speed. That means we have to calculate delta V. Well, we can do this. We know delta V over V equals 0.01. That means delta V, the absolute uncertainty in speed, 0.01 times V. Just cross multiply. 0.01. Our speed V, we can calculate that. Speed is distance divided by time. V equals X over T. X was 25 centimeters. T was 4.5 seconds. So our V, our speed, is 5.56 centimeters per second. So we pop that into our uncertainty calculation, times 5.56 centimeters per second. And we solve that and we get 0.06 centimeters per second. So that's the absolute value in your uncertainty. That's the absolute uncertainty in your speed. Okay, so hopefully that's going to take you right through question 1. Then the next uncertainty calculation you come to will be finding the uncertainty after you type all of your trial values in the computer. So let's have a look at how that's going to work. So you're going to get a set of trial data, and let's say our trial numbers that you type into the computer will be 1, 2, 3, 4, 5, 6, 7, 8. Let's say our speeds will be 0.464, 0.488. There will definitely be some scatter, 0.410, 0.499, 0. So you'll have a set of speeds, you'll have your trial numbers, and then you're going to type those in your Logger Pro. So you'll have clicked open your icon, you'll type those in, and you're going to get a graph that looks something like this. So you'll have your horizontal will be your speed, your vertical will be your trial numbers, and you'll just have a set of dots that looks like this. Okay, something like that. To analyze this data, what you do is you click Analyze. After you click Analyze, you hit Statistics, and then a window will pop up with some information in it. The information you need will be the mean. So it will say something like the mean is 0.4521. And the standard deviation, that's labeled stand div. The standard deviation will be 0.03195, for example. And then the last thing will be the samples. That's how many points you had. That's 8 points. Okay, so this is the information you're going to use. This will be your average velocity. So that will be the average of all these trials. To get your uncertainty, you need to calculate the standard error. So delta V, that's your uncertainty, the absolute uncertainty. That's your standard error. And you calculate that by doing the standard deviation divided by the square root of the number of points. So this one, you'll haul out your calculator and do this one. 0.03195 divided by the square root of 8. And if you do that on your calculator, you'll probably get 0.01. And then you write down your answer in the correct form. So your uncertainty is 1 sig fig. This has 2 places after the decimal. So you round this, your mean, to 2 places after the decimal. So V is 0.45 plus or minus 0.01 meters per second. Okay, so that should take you through the bits of uncertainty you need to take you do lab number 1.